We're going to start our conversation about acids and bases and ultimately their equilibria by defining what acids and bases are, and then talking about some of the basic concepts. Acids have been known since antiquity. They were compounds that if you tasted them, please don't do this at home. We don't do this anymore. They tasted sour. If they touched your skin, they would burn and actively tingle immediately. They had some characteristic reactions. If you reacted them with metals, right, they would react, a metal plus an acid, a generic acid, would tend to make hydrogen gas plus a compound, right? In this case, given the stoichiometry I've established, and we call that compound a salt. So you would get flammable hydrogen gas and then what we now know is an ionic compound, right? So salts were identified sometimes out of these reactions. Right. The other characteristic reaction is if you had carbonate rocks, like calcium carbonate or magnesium carbonate. If you reacted those with acids, you tended to get, again, a salt, right? A calcium or magnesium salt, but the other product was carbon dioxide gas and water, and we'll talk about that. So again, there were some characteristic reactions of acids that have been known since antiquity. It was our favorite dead French chemist, Antoine Lavoisier, that really started to chemically characterize what acids were and what their characteristics were. We know that Lavoisier did a lot of study of combustion reactions. And he realized that if he did combustion reactions of nonmetals, so for example, carbon plus oxygen making carbon dioxide, right? He would get these gases or oxides, or sulfur plus oxygen. Let's try to balance this, making sulfur trioxide, or phosphorus plus oxygen. Okay, I cheated balancing that one. Right? Right, and let me get my stoichiometry right first. Right? So he got these materials, some of which were gaseous, but some of which were solid. But what he found was all of these would react with water right? Oh, let me make sure. Got to get my stoichiometry right here. Right? To make acids. Here we've got carbonic acid. Here we've got sulfuric acid, and here we've got phosphoric acid. Right? So when nonmetals were burned in oxygen, you got products that when reacted with water would make acidic solutions, right? And so the name oxygen meant acid generator, right? So Lavoisier identified the basis for the whole group of acids, that we call oxyacids. Okay? Okay. So, on the other side, bases, right, in contrast to acid, solutions of bases, again, don't try this at home, taste bitter, right? They damage tissue. Without burning. That is, if you've got a solution of a base on your skin, you often don't feel it. It can be damaging your tissue, but it doesn't burn acutely the way a solution of an acid will burn. And so you often can't feel a base doing damage. And so that makes bases actually often more dangerous than acids, because you can't feel the damage occurring until it's too late. So those are characteristics of bases. The things that we associate with bases, right, are things like lye, right? Yes, if you heard a ding, my phone did just go off in my pocket. So lye is what you get, right, when you boil down the white ash from wood, right? So if you burn wood all the way down to a white ash, and then you dissolve that white ash in water, what's mostly in that ash is combinations of sodium oxide and potassium oxide from the ionic compounds, maybe a little bit of calcium oxide, right? The ions in the living wood are converted into oxides. If we take those oxides then and put them in water, and we will talk about this again in a few minutes, sodium oxide plus water will react to make 2 moles of sodium hydroxide aqueous. The same thing is true for, potassium oxide. Oh, it would help if I would write my formulas correctly, though. You guys can't let me get away with this stuff. Sodium oxide, right? If we do calcium oxide plus water, you get calcium hydroxide. And then if you boil that down, you can get a concentration of a fairly strong basic solution that we call lye. So lye is made by boiling wood ash to concentrate the hydroxides that you get from the reaction with the oxides left behind in that white wood ash. One of the characteristic reactions of bases is hydrolysis of fats, which also explains partly the way bases can damage tissue. So if we have a typical fat, and let me draw this, I didn't want to do that. Let's see here, that would be this. Why did it move? There we go. Okay, so after a little resizing there, right? So if we have sort of a typical fat here, so we got 1, 2, 3 carbons, O, double bond, O, no. Come on, Joe, draw your stuff right. O, C, double bond, O, and then a long chain, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Long chain, and then an O, C, double bond, O, and then a long chain, and then an O, C, double bond, O, and then a long chain, right? That's what the structure of a fat looks like, where every corner is where a carbon with the appropriate number of hydrogens would be, okay? So if you've got fats like this, and this is one of the things that they would use this lye for, right? If you react this with your lye, and let's just use sodium hydroxide as an example of one of the components in the lye, in water, right? And I'm not really trying to balance this, right? You would get a 3-carbon alcohol called glycerol, or impure preparations of it are called glycerin. So if you use glycerin soaps, it's got this left over, and then what's left behind is this squiggle, 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 right? So C double bond O, O minus, squiggle, 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 and C double bond O, O minus, squiggle, 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 as A, in this case, sodium salt. Right? So we get these sodium salts of what we call carboxylates. And what we call those compounds is those are soaps. Right? So when we talk about lye soap, people, pioneers making lye soap, they would take their wood ashes, they would boil them down to make a concentrated solution of the lye. They would take animal fat, they would boil it with the lye, it would hydrolyze this, and then, right, these soap molecules, you've got ionic parts that will ionize and separate and interact with water, and then you've got long non-polar parts that will interact with fatty dirt, and that's the way soaps work. And so soaps come from the reaction of bases lye with these structures in animal fats. And we can get similar reactions in the hydrolysis of proteins, right? Proteins can be dissolved or can be hydrolyzed in lye solutions. And so that is a characteristic reaction of lye. And that characteristic reaction explains another property of soaps, or of bases. Bases, if we get them on our skin, the skin feels slick. Because on our skin, the oils in our skin have molecules like this. And so the bases, if you get a solution of a strong base on your skin, it will start hydrolyzing that, turning that into soap on your skin, and your skin will feel slick as an indication that you have gotten some strong base on your skin. Now, it took a while for people to identify and sort of bring together acid concepts. One of the first scientists who really tried to bring together and summarize acid and base concepts was our favorite dead Swedish chemist, Svante Arrhenius, right? Remember, we talked about Arrhenius before. Arrhenius identified activation energy as well. But in 1884, Arrhenius, studying ionic solutions, published a definition of acids and bases. And so Arrhenius' definition of acids and bases looks something like this, right? So to Arrhenius, acids well, let's go with R. Let's go with, all right, acids are compounds that, when dissolved in or reacted with water, cause the concentration of free hydrogen ions and remember the hydrogen ion is just a proton, so often those words are used interchangeably, to increase. Right? Still sticking with Arrhenius, right? To Arrhenius, a base is probably a better word to use would be substance that, when dissolved in water, causes the concentration of free hydroxide ions to increase. Okay? So those are definitions that we definitely need to know.